Hello everyone. I welcome all of you to our next module, Agro-Robotics Lab, Designing a Tomato Crafting Robot. Our first class in this module is Tomato Crafting with Robots, Build Your First Gripper in Tinkercad. Before we jump into the simulation, let's understand the agricultural and the robotics basics behind this activity. So, grafting is basically a horticultural technique where the tissues of two plants are joined so they grow as one. We have two important components here. The first one is the rootstock. This is the root portion which is chosen for disease resistance and strong growth. The second important component is the scion. This is the upper portion which is chosen for fruit quality and yield. Together, they are going to create a stronger, healthier tomato plants with high productivity. So farmers do graft the tomatoes in order to increase the resistance against the soil-borne diseases for the better yield and to ability to grow the longer crop cycles, especially in greenhouses. Traditionally, grafting was done manually using the tiny clips and razors, but today, robotic grafting machines can grip the stems gently and cut them precisely as well. We do need robots in order to do this grafting. So, robot is a machine that can sense, think, and act, and you see robots everywhere around us. In agriculture, robots can plant, harvest, and yes, it can even graft the plants. For grafting the robots, it needs a sensors in order to detect the stems. It needs some actuators, or you can call as a motors, in order to grip and move the parts. Then there's a small logic or a code which decides when to grip. So motors, it converts the electricity into the movement. Without motors, the robots cannot grip, rotate, or manipulate anything. In robots, we use three different types of motors: a DC motor, a stepper motor, and a servo motor. A DC motor, it spins continuously and it is good for the wheels. A stepper motor is good for positioning. So whenever I require any movement in small steps, stepper motor is good. Servo motor, this is the hero of the story. It involves precise angle control, which means it is perfect for gripping the delicate tomato stems. So servo motors are generally used because it has a very good precision, stability, and ability to hold the exact angles. With this basic understanding, let's move to the Tinkercad now. So I request all of you to go to tinkercad.com and then click Login. Try to log in with your personal accounts. Click Sign in with Google. Choose your email ID and try to enter inside the Tinkercad. Click Create Circuits. In order to do this project, we require two components. One is Arduino Uno, another one is servo motor. So try to bring both of them onto your dashboard. We have got the Arduino Uno R3. R3 represents it's a revision, it's a version 3. The second important component is the servo motor. You can see the name as micro servo in Tinkercad. A servo motor has three important connections: signal, power, and ground. Now it's time to connect the servo motor to the Arduino board. I'm connecting the signal of the servo motor to the 9th pin of the Arduino Uno. You can give to any of the digital pins. You see that you're using those respective pins correctly in the code. Next, we have the power. Servo motor, it requires 5 volt. So, the power of the servo motor is connected to the 5 volt of the Arduino Uno. The ground of the servo motor is connected to the ground of the Arduino Uno. Try giving a name for your project. With this, the basic connections are done. Now let's try to code it. In order to do the coding, please click the option Code available in the Tinkercad. In Code, we have 3 different edit modes available. Please choose Text. Then Continue. After switching to the text mode, it's time to write our code. Delete the previously existing code. The first line is trying to include the library for the servo motor. Hash includes servo.h. So this is like telling the Arduino, please give me a special toolbox that knows how to control the servo motors. Then we write servo gripper. This creates a servo object called gripper. It's like a nickname for the robot's hand. Next is void setup. Inside void setup, we are going to mention where we have connected the signal wire of the servo motor. Gripper dot attach 9. So here we tell Arduino the servo signal wire is connected to pin 9, so send all messages there. If you are using a different digital pin, you ensure that you are mentioning the same in the code. Next, we will move on to void loop. In the void loop, we are going to open the gripper and close the gripper halfway. In order to do that, we have a command called gripper.write. So gripper.write 0. This means we are going to open the gripper. After opening the gripper, we are going to give a delay for 1000 milliseconds. So it's like waiting for 1 second. Next, we are going to close the gripper halfway. In order to close the gripper halfway, we give the command gripper.write 90. So gripper.write 90. So this ensures the gripper closes halfway. Then we give a delay for 1 second. This represents our robot is opening and closing the tomato crafting clip repeatedly. Let's try to start the simulation now. So you can witness the robot is opening and closing the clip repeatedly forever. So till you give stop simulation, this particular loop is going to run forever. So we have seen how to open and close the gripper halfway. Now let's try to understand the multi-grip presets. Multi-grip presets ensures the servo steps through these angles one by one, teaching us how the robots control the gripping pressure in the real life. So we have ensured we have 4 different gripping angles here. 0 degree for open, 45 degree for gentle grip, which is safe for the thin stems, 90 degree for medium grip, and 120 degree firm grip. So this can crash the tender stems. Let's try to code this in Tinkercad and see how the servo steps through these angles one by one. Let's go to Tinkercad now. We are going to edit the same code. Let me give stop simulation. And now it's time for us to give the multi-gip presets here. So there is no change in the void setup. Rather, in the void loop, we are going to make some changes. Let's start with a gentle grip. Gripper dot write 45. Please ensure there is a semicolon after each and every line in your code. Then I'm giving a delay of 1500. This delay is completely left to the user. Next, I want to ensure there is a medium grip. So gripper dot write 90. So 90° is a medium grip. Give a delay again. Next, I'm going to give a firm grip of 120. Next, I'm going to release the grip. The delay time is being given by the user and it is completely user dependent. So with this understanding, let's try to give start simulation now. So we have ensured there is a gentle grip, medium grip, firm grip, and then we are going to release. Let's give start simulation now and look for the changes. So you can see there's a 45-degree rotation, 90-degree rotation, 120-degree rotation, and then it releases. So this is how a basic gripping can be performed in the servo motor. So tomato crafting needs precision, consistency, and gentle handling. So servo motors, it makes it accurate and repeated gripping is also possible. I hope you understood the basics of how a robotic gripper works in tomato crafting. In the next session, we will build on this and make our robot smarter with sensors and even more logic. See you all in the next session. Until then, as I always say, happy learning.